Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we are going to discuss Nernst equation, which is a non-standard version of voltage reading or electromotive force. Okay, before this we have learned how to calculate E naught cell. So E naught cell tu, if you still remember, is measured at standard condition, which is pressure 180 m, temperature 25 degrees C, and if we have aqueous solution, it should be 1 molar. So what happened if the condition is non-standard? It will affect the voltage reading. It will affect the electromotive force of the cell. So when we have a different temperature, pressure and concentration, we have to calculate differently the electromotive cell or the voltage reading. Therefore, we cannot call it E naught cell any longer. We should call it E cell, okay, without the naught. Okay, if you notice, this is the one that we have learned earlier. Okay, E naught cell. Okay, so this is the one that is at non-standard condition. So when this scientist Nernst make an experiment where the reaction where the cell is being constructed at non-standard condition, he found out that the voltage reading is can be calculated using this formula. E equals to E naught minus RT over NF ln Q. Okay, if we write it down in normal form, it will look more or less like this. Okay, so this is E cell, this is E naught cell, standard reading, minus RT over NF ln Q. Okay, Q ni is our quotient, reaction quotient. If you still remember, we have learned Q during chemical equilibrium, where it is actually ratio between concentration of product and reactant. So it should be concentration of product to the power of its stoichiometric coefficient divided by concentration of reactant to the power of its stoichiometric coefficient. That is if the product and reactant exist in the form of aqueous solution. So if the product and reactant exist in the form of gas, we will measure using partial pressure lah. Partial pressure product to the power of its stoichiometric coefficient. Product pak. Sorry. Yang ini reactant to the power of its stoichiometric coefficient. Okay, so since ln is much inconvenience to be used in calculation. Okay, since log is pretty much more often used in calculation, so if we change ln into log, then the equation will be a bit different. Okay, biasanya ln ni is not preferable when we are doing calculation, sebab kita jarang gunakan ln, tapi biasa digunakan ialah log 10. Okay, bukan ln ni natural log, tapi yang biasa kita gunakan ialah log 10, log power 10. So E cell will be E naught cell. Okay, ada perubahan sikit, dia jadi negative 2303 RT over NF log Q. Okay, Q is still the reaction quotient lah. Okay, so if the temperature of the cell is constructed at 298.15 Kelvin or 25 degrees C, Kalau temperature-nya 25 degree C ataupun 298.15, then we can simplify the equation by substituting 298.15 Kelvin ni dalam equation ini, and then we are going to end up with a much simpler equation. Maksudnya walaupun dia non-standard condition, tapi temperature dia saja yang 25 degree C. Temperature dia standard, tapi lain-lain tu maksudnya tak standard lah. Mungkin dia punya pressure ke yang tak sama, pressure dia bukan 1 atm, concentration dia bukan 1 molar, tapi temperature dia 25 degree C, which usually happen that way lah. Selalunya yang kita ubah-ubah, parameter yang kita ubah-ubah dalam kita punya sel ni ialah concentration kita punya elektrolit, ataupun pressure of the gas yang kita guna dalam sel tersebut. Temperature ni biasanya kita depends on room temperature saja. So selalunya temperature tu tak ada masalah. So bila temperature is 25 degree C, kita boleh simplify the equation and it will become this form, 0.0592 over N log Q. So it is a much simpler version of Nernst equation. Okay, asal dia kita ada yang atas ni. Okay, yang ni yang asal. Lepas tu kita instead of using ln, natural log, we use log 10. So we get the second version. And then kalau dia berlaku at 25 degree C, we can use the third version, which is the much simpler one. So memang selalunya yang kita akan guna ialah yang the third equation lah, sebab dia lebih senang untuk digunakan. Okay, dan temperature kita pun biasanya berlaku dalam suhu, lebih kurang suhu bilik. Okay, so the equation indicates that the electrical potential of a cell depends upon the reaction quotient of the reaction. As the redox reaction proceed, reactants are consumed, thus concentration of reactant decreases. Conversely, the product concentration increases due to the increase in product formation. Okay, so kalau kita tengok pada equation ini, we can see that the E cell depends on Q. Okay, dia depends on Q. So Q kita ni tadi apa? Q ialah concentration of product and concentration of reactant, ataupun partial pressure product, partial pressure reactant. And not only we can start with non-standard concentration or non-standard partial pressure, tapi sebenarnya along the reaction tu itself, since kita punya produk tu akan makin bertambah dan kita punya reactant tu akan makin berkurang, sebenarnya semasa dalam proses sel kita tu sedang berlaku redox reaction pun, kita punya E cell tadi tu ataupun voltage reading tadi tu boleh berubah. Walaupun kita start with standard condition, but we can see that as the reaction goes on, the voltage reading will be different. Voltage reading tu akan berubah menjadi non-standard as the reaction goes. Okay, walaupun kita start dengan standard condition. Apatah lagi kalau kita tak start dengan standard condition lah. Kalau kita dah tak start dengan standard condition, of course lah E cell kita tak sama dengan E not cell. Okay, kalau even kita start dengan standard condition pun, mungkin kalau kita biarkan lama, E cell kita tu akan sel kita tu akan mempunyai reading yang berbeza. Okay, kenapa dia jadi begini? Is because as the reaction proceed, reactant are consumed and the concentration of reactant will decrease. Okay, and then oppositely for product, the concentration will increase and the concentration of product will increase. So dia menyebabkan Q kita tu nanti berubah. Okay, as this happen, cell potential gradually decrease until the reaction is at equilibrium, which Q is equals to K. As the reaction continues, kita nanti akan sampai satu tahap yang kita punya reaction tu akan capai equilibrium. Okay, bila capai equilibrium tu, maksudnya kita punya potential between anode and cathode tu dah sama. So the reaction cannot happen any longer. Kalau kita biarkan lama, reaction tu asyik berlaku saja, concentration reactant terus berkurang, concentration produk terus bertambah, dia akan sampai satu tahap yang cell potential anode dan cathode tu akan jadi sama, equilibrium. So bila dalam keadaan ini, since dia dalam keadaan equilibrium, so Q kita tadi will be equals to K. Remember K? K ni ialah equilibrium constant yang kita belajar masa chapter semester 1 dulu. Okay, dia ialah equilibrium constant. Q tu ialah reaction quotient. Q tu ialah ratio at any time except for at equilibrium. K pula ialah ratio at equilibrium. So at equilibrium, Q kita akan jadi K. Okay. And kita punya bacaan, kita punya E cell akan jadi zero. Sebab pada waktu tu elektron dah tak boleh flow lagi from anode to cathode, since the potential between anode and cathode is now the same. Dia dah tak boleh nak pindahkan lagi elektron daripada anode ke cathode. So redox reaction tu dah tak boleh berlaku dah. Sampai satu tahap yang redox reaction tu dah tak boleh berlaku. So bila tak boleh berlaku, kita dah tak ada bacaan lah pada kita punya voltmeter tu. So E kita akan jadi zero. Dah tak standard condition lah pada waktu tu, sebab concentration produk dah terlampau tinggi, concentration reactant dah terlampau rendah. Okay, so when this happen, if we substitute this value to our Nernst equation tadi, Nernst equation yang ketiga ni tadi, kita masukkan E cell is 0, sebab dah tak ada bacaan kan, E cell 0, Q kita ganti dengan K. Okay, so nanti kita akan dapat this equation. So E naught cell minus 0.0592 over N log K. And when we rearrange the equation, we will end up with this equation. E cell divided by 0.0592. Okay, so kita ada 4 versions of Nernst equation depending on which situation that we are given. Okay, selalunya kita tak pakai yang the first equation tu tadi. Yang first version ni selalunya kita tak pakai. Okay, the second equation kita akan guna bila semua dalam keadaan non-standard. Kita punya temperature pun non-standard, kita punya pressure pun non-standard, kita punya concentration pun non-standard. The third equation yang kita akan selalu guna ialah bila temperature standard, temperature 25 degree C ataupun 298.15 Kelvin, tapi pressure dan concentration non-standard. And then last sekali, equation yang keempat ni ialah bila E cell kita zero, iaitu bila kita punya E cell telah capai bila kita punya cell tu mencapai equilibrium. Okay, now we are going to do this question. Okay, calculate E cell for the specified reaction. Okay, we have if you look at the cell notation between zinc half cell and ferrum half cell ni, you can see that the aqueous solution is not molar, 1 molar. The concentration is not 1 molar. So automatically we know that this is supposed to be using Nernst equation lah. And then kalau tengok question pun dia memang dah kata calculate E cell, tak ada not kan. So maksudnya memang non-standard condition lah. Okay, so when we want to calculate for the equation, E cell, we can assume the temperature is at 25 degrees C if the question does not mention about the temperature. Okay, macam sekarang ni temperature dia tak sebutkan, so we can safely assume that the temperature is at standard condition. Temperature dia 25 degrees C. So we can use the simplified version of Nernst equation lah. So tak perlulah guna yang panjang, kita boleh guna yang ringkas, which is this one. E cell equals to E naught cell minus 0.0592 over N log Q. Okay, so if you look at this Nernst equation, kita ada E naught cell, which means that kita kena kira dulu dia punya standard standard cell potential. Kena kira dulu. Walaupun kita sekarang ni nak mencari dia punya cell at non-standard condition, tapi mesti ada yang standard condition punya juga, sebab dalam formula kita ada. Okay, next we have N. Okay, N tu ialah number of mole of electron that is involved in the reaction. Berapa banyak elektron yang terlibat dalam kita punya redox reaction ni, berapa banyak yang di-release oleh anode dan berapa banyak yang receive oleh cathode. So in order to do that, we need to have balance equation. Kita kena ada dulu half equation dan kena ada overall equation, baru kita boleh tahu berapa banyak elektron yang involve lah dalam kita punya reaction ni. Okay, last kali kita ada Q. Again, Q ni ialah reaction quotient, where concentration of product is divided with concentration of reactant to the power of its stoichiometric coefficient. Since kita perlukan stoichiometric coefficient dan kita perlu determine siapa produk siapa reactant, therefore kita perlukan balance equation tadilah, overall equation tu kena ada. Okay, so first let's calculate the E naught cell dulu. So E naught cell, if you still remember, is E naught cathode minus E naught anode. So this we can get from the SRP table. Okay, saya dah bagi SRP table kat sini. Okay, let's go and look for kita punya zinc. Zinc 2 plus becomes zinc solid. Okay, ni negative 0.76. Satu lagi ialah ferrum 3 plus to ferrum 2 plus. Okay, jangan salah cari bukan ferrum 2 plus ke ferrum solid tau. Dia ialah ferrum 3 plus to ferrum 2 plus. So ini kita punya nilai. So this will be our cathode. Fe3 plus tu cathode sebab nilai dia lagi tinggi. Zinc nilai dia lagi rendah, so dia jadi anode lah. Okay, patah balik. So kita punya ferrum tadi is positive 0.77. Zinc tadi is negative 0.76. So kalau kita calculate ni, kita akan dapat positive 1.53 volt. Okay, settle E naught cell. Now to find number of mole of electron and also Q. So like I have mentioned earlier, we need to write the half cell equation dulu. So at anode, zinc change to zinc 2 plus, the oxidation. At cathode, we have ferrum 3 plus changing to ferrum 2 plus kan, so dia receive 1 electron aja. Okay, so since number of electron is not the same with both equation, so the second equation needs to be multiplied with 2. Kita kena multiply dengan 2. 2 electron, 2 Fe2 plus. baru sama number of mole of electron, then baru can cancel lah. So then we combine the equation. Zinc. Okay. So now we can substitute inside our E cell. Okay, E naught cell tadi kita dah kira positive 1.53 volt minus 0.0592. Okay, N is number of mole of electron yang balance. Berapa banyak yang transferred, berapa banyak yang donate dan berapa banyak yang accept. So, yang balance ialah 2 elektron lah, sebab kita kena multiply 2 dengan cathode tadi. Sebab berapa banyak yang di donate, banyak tu jugalah yang di receive. Okay, so 2 lah. And then log. Okay, kita senaraikan dulu siapa kita punya produk. Okay, produk kita zinc. Zinc 2 plus. Siapa lagi? Ferrum. Fe2 plus. Okay, Fe2 plus, dia punya stoichiometric coefficient is 2. So, we have to put power 2. Okay, divide with reactant. Okay, reactant, zinc tak perlu masuk because zinc is in the form of solid. Okay, remember we have learned in chemical equilibrium, pure solid and pure liquid is not involved in the calculation of reaction quotient. Tak payah masuk dalam pengiraan ratio sebab concentration dia dianggap constant. Okay, bila kita ada heterogeneous reaction. So, zinc solid tu tak perlu. Yang perlu is Fe3+. Again, Fe3+, stoichiometric coefficient dia 2, so we have to put power 2. Okay. And then we calculate as usual lah. Nanti masukkan nilai-nilai concentration yang dah diberi dalam question. So zinc is 0.1, Fe2 plus is 0.1, Fe3 plus also 0.1, power 2. So ini kita boleh cancel ni. Okay, so nanti bila kita calculate, we'll calculate macam biasa. Then the answer should be more or less the same like answer yang saya dah bagi ni lah, positive 1.56 volt. Okay, let's do another example. Okay, this question give us for the zinc copper redox reaction. What is the equilibrium constant for this reaction? Okay, since the question require us to give equilibrium constant, so we can assume that this reaction happens at equilibrium lah. So when the reaction is at equilibrium, we can straight away use the fourth equation, fourth Nernst equation tadi, iaitu yang kita dah ganti Q dengan K, and then kita dah ganti E cell with 0. So boleh terus guna yang ni. Okay, boleh terus guna yang tu. Okay, so again, if we want to use this formula, you can see that we still need to calculate for E naught cell, and we still need number of mole of electron, N. Okay, so we are going to calculate E naught cell first. Okay, E cathode minus E anode. Okay, so if according to the standard reduction potential table, okay, kita cari zinc dengan copper. Copper ni biasanya dia duduk tengah-tengah. Okay, ni copper. Okay, ini untuk copper 0.34. Zinc, zinc kita dah cari tadi, negative 0.76. Okay, so kita boleh guna tu untuk calculate kita punya E naught cell. So cathode tadi yang duduk atas ialah carbon, ialah copper, positive 0.34. Yang duduk kat bawah tadi zinc is 0.76. So kalau kita kira ni dia jadi positive 1.10 volt. Okay, and then as for number of mole of electron, as usual we need to write the half cell equation for both anode and cathode, and then write the overall equation lah. Okay, so for anode, okay, zinc is our anode because dia punya E naught cell tu rendah tadi, so it will goes oxidation, while cathode is copper cell, so it will undergoes reduction. And if we can see here, number of mole of electron is already balanced, so we can straight away cancel. So kita dah dapat lah number of mole electron involved, which is 2. So boleh terus masukkan dalam kita punya formula. So number of mole of electron is 2, E naught cell tadi 1.10, okay, divide dengan 0.0592. Okay, kalau kita lockkan sebelah kanan tu and shift lockkan, at the end of the day kita akan dapat actually dia lain sikit dengan yang saya bagi ni. Dia ialah 1.45 times 10 to the power of negative 37. Lari sikit lah. Okay, no unit because K is equilibrium constant. Remember we have learned before, equilibrium constant don't have unit. So this is how we use our Nernst equation depending on the situation given in the question.